Hello everybody. Today I'd like to work on with you a problem from a book called Related Rates. So this is probably our first example of related rates. What we have is the profit function. The profit is in dollars and X is units. So units of product, profit from the units of product. They ask what rate per day is the profit changing when the number of units produced and sold is 100 and is increasing at a rate of 10 units per day. So at what rate per day is the profit changing? So what they're asking for is at what rate is the profit changing, DP, with respect to time. That's really what they're asking in this question is, at what rate is the profit changing with respect to time? Notice it's a related variable to both X and P in this case, because they go on to say, find this dP dt at 100 units sold, at 100 units, and they go on to say, in this question, the production, the units, is increasing at a rate of 10 units per day. So the units are increasing at a rate of 10 units per day. So the units, the change in the units per day, is 10. So what we have is we want the change in profit per day. We got the change in units per day. And we're looking at a particular number of units, 100 units. So how would one solve this? Well, this is, again, a related rate question. What we're going to do is, I would love to find dP dt. To do that, I look across and say the only way to find dP dt is to take the derivative with respect to t, because that's what this is. The denominator tells me what I'm going to do in all these related rate questions. It's the derivative with respect to t. So I'm going to take this whole equation, implicitly take the derivative with respect to t. How does that happen? Well, you take the derivative of p. The derivative of p should be 1, but I do not know if that function p is a variable of t or not, so we're going to multiply by the chain rule by dP dt equals the derivative of 180x, well, that should be 180, but that x could be a function of t, so by the chain rule is times derivative of x with respect to t. We move on. The derivative of x squared over 1,000, well, that 1,000 is a constant, so that doesn't play any role. The derivative of x squared is 2x. So we really have 2 over 1,000, or 500. So we have x over 500 by algebra. But of course, again, dx dt, because I do not know if x was a function of t or not. Last but not least, the derivative of 2,000 is 0, so I don't write it. So one more time. The derivative of p should be 1. But it's going to be dP dt because I took the derivative of this whole equation with respect to t. That's what I did. I took the derivative with respect to t. And if you followed my previous videos on implicit differentiation, if the bottom letter does not match the top letters here, then you're going to have to multiply by the chain rule. In this case, that's a p, so it's dP dt. That's an x, that's a dx dt. If there was a y, I'd do a dy dt, so on and so forth. And so, why is this here? Just to review one more time. The derivative of x squared over 1,000. Well, the 1,000 is a constant. We have a constant rule that states we can take the derivative of x squared, which is 2x, and just keep the constant. And 2 over 1,000 is 1 out of 500. And that's what I did there. Good algebra. So there's my equation. Now I want dP dt. Notice it's already solved for. dP dt is this equation right here. If I had dx dt, and a particular x, I could solve for dP dt. So my answer in this question, the rate at which profit is changing, is nothing more than 180 times the rate of x is changing, the units are changing, which is 10, minus x over 500. We said x, we're staring at 100 units currently, so x is 100, so 100 over 500, times, once again, the rate dx dt, which was given as 10. So this is just calculator work, and we get our answer. So let me get my calculator. Apologize for me leaving the screen. We get 100, well, come on now. 180 times 10 is 1800. Minus, this is 1/5 times 10, or 2. Right? 1/5 of 10 is 2. And so 1800 minus 2 is 1798. And so this would be per day. So we're looking at a profit of changing of $1,798 per day, because we're looking at 100 units, and we're looking at the rate of production, the rate of units changing at 10 per day. Given these two facts, that's what they are, givens. Given these two facts, can we determine the rate of profit change? The answer is yes. By utilizing related rates, we can find the answer we're looking for. DPTT, the rate at which profit is changing with respect to time, is $1,798 per day. Thank you guys for watching this video on related rates. We hope to see you again.